Hi, my name is Isabelle, and I am a student at Crystal Springs Upland School in Hillsborough, California. Today I'll be presenting Learning to Listen, Machine Learning for Intonation Error Detection in Violin Performance. I've always been interested in music, particularly violin, as well as AI and machine learning. I wanted to find a practical application for machine learning in music and learn how it can be used in different ways. This project presents a web application that uses machine learning to help beginner violinists improve their playing. It provides personalized and specific feedback on the musician's intonation and tips on how they should practice. The problem this program addresses is that it is difficult for beginners to recognize differences in the pitch they are playing and the pitch they should be playing. This means that they don't know if they are making mistakes or how to fix them. The solution for this is this program, which detects small intonation errors and provides feedback on these errors. This will help musicians to improve their intonation as well as develop their own ability to recognize these errors in the future. Here is the project demo. The first step is that the violinist uploads the score of the music, an audio clip of them playing, and the tempo they are playing at. Here is an example. The score of the piece I am playing, I played when I was little and I really enjoyed it. It's called Ashokan Farewell. And here is a clip of me playing my best, so relatively in tune. And the tempo here that I inputted is 80 beats per minute. Here is the second example of the same excerpt from the piece, except that I played a couple of notes out of tune, so you can hear the difference. There are two notes out of tune, and when you input these two examples in, you can see the different feedback that it provides. So the second step is that the violinist receives feedback on their intonation and practice tips. For the first example, since all of the notes were in tune, it says, "Great job and keep up the good work." For the second example, there are two places where I played out of tune, and it provides the intonation correction with information on which note was out of tune, if it was too sharp or too flat, what time it was played at, and how many cents off it was. In addition to this intonation correction, it also provides a practice tip to help you practice that section. And the practice tip for the note that was too sharp is to lower your finger slightly to bring the pitch down. The third part of this is the violinist will receive reasoning on why that feedback was provided. The reasoning includes every note in that piece, and for each note, it has measure, time, and how many cents off it was. For the first example, all of the notes are in tune. While for the second example, with the incorrect notes, there are the two places where one note was too sharp and one note was too flat. Here is the flow of the project. The first step is that the user will input the audio clip, image of the score, and the tempo. The image of the score is sent to a program called Autoveris, which will parse this image to get the correct pitches, so the pitches that the violinist should be playing. The audio clip inputted is sent to a program called Crepe, which will detect the pitch every 10 milliseconds. So for these different parts, first, how does Autoveris work? Autoveris uses optical music recognition, or an OMR engine. And what it does is it converts scanned musical scores into a digital format, such as music XML, which is a file format for sheet music. Autovirus can recognize different musical elements in the sheet music, such as lines, beams, note heads, and other textual elements. In this program, Autovirus will process the image of the score, the PDF, and turn it into a music XML file, which has information about the correct pitches and at what time each note occurs. The program that processes the audio clip is a pitch tracker. So there are several different pitch tracking methods, and here are a few of them. Ultimately, I decided to use Crepe, which is more robust to violin timbre and dynamics, has pre-trained models available, and outputs the pitch confidence of each prediction. The most important pro of Crepe is that the overall accuracy is much higher than the other pitch tracking methods, even though it is slower. So what is Crepe? Crepe stands for Convolutional Representation for Pitch Estimation. And what it does is it uses a convolutional neural network, or a CNN, to estimate the fundamental frequency of an audio signal. How it works is it takes the raw audio waveform and samples and normalizes it, and it takes these samples and feeds it into the CNN. And the CNN has many convolutional layers that will extract high-level features from this waveform. And the last layers will output a probability distribution across 360 bins. And based on this output, the bin with the highest probability is chosen as the frequency prediction. In this program, Crepe is used to estimate the pitch of notes played in the audio. So here is the flow again. The image of the score is processed by Autovirus to get the correct pitches, and the audio clip is processed by Crepe to get frequency predictions every 10 milliseconds. The last part of the input was the tempo, and the tempo is used to align the correct pitches with the frequency predictions so that they can be compared. Using different calculations, the time of each note of each correct pitch from Autovirus is calculated using the tempo, and the difference between the correct pitches and the frequency predictions is used to generate the feedback. There are a few limitations of this program. The first is if the tempo that you input is different than the tempo that you play at, the output will be inaccurate. This is the same for if the musician plays rhythm incorrectly, as the correct pitches and the Crepe frequencies will not align, and it will produce an inaccurate output. The second limitation is octave shifting. Sometimes Crepe will predict a frequency that is either an octave above or an octave below what was actually played. And this will produce an out of tune note, even though the note could actually be in tune. Lastly, I'd like to talk about next steps for this project. I would like to create my own pitch tracking ML model similar to Crepe, as I would like to learn how exactly Crepe works and how you would go about training a model like that. I would also like to be able to add more features so that the program can detect rhythm and dynamic mistakes in addition to the intonation mistakes. I would also like to be able to generate feedback for the musician about these aspects of their playing and practice tips to improve their rhythm and dynamics. here are my references. I would also like to thank my mentor, Sarah, for all her guidance and help in this project. Thank you so much for listening.